Hey guys, so we are in the last unit for this class and we made it. I'm pretty excited about that. I'm not sure how far we'll get, so we'll probably look at it in sections, but the first big section of this is what I have up here on the board, and it's about something called oblique triangles and the laws of sine and the law of cosine. Okay, so oblique triangles, they're just referring to triangles that are not considered right triangles, okay? So they can have acute or obtuse angles. And we are now going to branch out and learn how to solve them because up to this point, we've only dealt with right triangles. That's all we've thought about. So the key thing here is to remember that what we know about sine, cosine, and tangent and all those relationships and ratios, tangent is sine over cosine. Well, actually, that one will stay. That one's good. But like sine is opposite over adjacent, and tangent is, I'm sorry, tangent is opposite over adjacent. Sine is opposite over hypotenuse. That kind of thing is going to go away when we do not have right triangles. And so we'll ease into this. And the good news is that these laws are not hard to use. Okay. So the first law that we're going to spend some time on is called the law of sines. Okay. So that's what I wrote here. We're going to deal with the law of sines, and that law looks like this. Okay. It's a big ratio, and there's three fractions there, three ratios there, because there's three sides to a triangle, and so you have to be able to deal with all three of them, or consider all three of them. But this is one of the easiest laws. Usually I have you memorize it, and it's not hard to memorize. But we're just going to see some pretty simple examples today of how this works. Okay? So you're going to see a law of sines problem come up in a situation like this, where I give you a triangle and I tell you that, so this would be example one. I tell you that A is 32 degrees, B is 81.8 degrees, and little a is 42.9 centimeters. Okay, and we're going to solve triangle ABC. Now, some key things you have to remember. A and B are capital letters, and so they represent angles. Lowercase a, b, and c always represent side lengths, okay? So that's really important. Also, when you're talking about a triangle, if I were to draw this triangle for you, okay, if we label this as A, you have to remember, and we talked about this, but it's been a while, you have to remember that if this is angle A, this must be side A, okay? So the labels mean something, and the angle is always paired with the opposite side of the triangle, all right? And so this is the relationship we have. I'll put B up here, but that means this is side B, okay? So you can use this relationship anytime that you have kind of like a matching angle and side pair, if you have their information, okay? If I gave you something about A, B, and C, you would not be able to use law of sines, and that's when we're going to have to get into law of cosines. But for now, we're good because we have angle A and side A. Okay, you have to have that match in order to use this law. So now, I'm going to just set this up. So I can find two things right now. I can find angle C just by subtracting. Everything we learned about angles of triangles is still true, okay? They all add up to 180 degrees. I can also find side B by using my new law. So I'm going to go ahead and say that angle C, I'm just going to get that out of the way. Angle C is 66.2 degrees. Okay, and that is 180 minus 32 minus 81.8. And now I'm going to set up my equation. So I have this. Now also I wanted to note that if you flip this and have sine A over A, that's fine. You just need to flip all of them. So it'd be sine B over B, sine C over C. Okay, so I wanted to mention that because my work has, oh, never mind. My work is this way. I typically tend to make my work so that the missing thing is on top. All right, so I have 42.9 over sine of 32 is equal to B over sine 81.8. All right, and so now I have a proportion, and all I have to do here is solve my proportion. So when you have proportions, remember you can cross multiply. So I'm going to do 42.9 sine of 81.8 equals B sine of 32. Okay, this times this equals this times this. And then I divide both sides by sine of 32. You can plug all of this into your calculator. We do need to notice that we went back to degrees for these problems, so you need to make sure that you're in the right mode. We've been in radians, so make sure you are in degree mode. And then you also need to be careful about your parentheses, okay? If you plug this whole thing into your calculator in one big step, you need to make sure that you have parentheses around the whole numerator and around the denominator. So if you type in, I would type parentheses 42.9 sine. Now notice when you open up a sine, it opens up another set of parentheses. So after we put in 81.8, I'm going to close those parentheses, and then I'm going to close the first set of parentheses. So I have two parentheses right then and there, divided by sine 32. Okay, and your answer should be the fact that, I don't have much room here, B is equal to 80.128 centimeters. All right, so there is the first side length that we need to find. All right, I do have to erase all this so I have room, but we also need to remember that, again, we are not dealing with a right triangle, so we cannot at this point say, ooh, now I can just use the Pythagorean theorem. Doesn't work anymore, okay? That's just for right triangles. So we have to go back to our law of sines and set this up again. So we have, I'm going to go ahead, and I should have left that one ratio, because I'm going to use the same thing, and then I'm going to set that equal to C over sine 66.2. All right, so we do the same thing. We cross multiply, we get 42.9 sine of 66.2 is equal to C times sine of 32. I'm going to divide both sides by sine of 32, so we end up with C is equal to 42.9 sine of 66.2 all over sine 32. All right, plug that into your calculator, type that, make sure you have enough parentheses, but you should end up with an answer of 74.071 centimeters. Okay, so you need to make sure that when you are turning something into me that I am looking for answers, that you circle or box out all of the final answers, because there's going to be a lot of work with some of these, and I need to be able to see where your final answers are. All right, so that is the basics, the first basic example of law of sines. So we're going to stick with the basics. We're going to try a few problems on our own. It's pretty straightforward so far. And then if you have any questions, you can reach out to me. And we'll do some more basic stuff tomorrow before we get into some of the some of the more trickier problems, they're coming, just like always. So try these easy ones. If you were lost or confused or you don't understand what are the steps, just reach out, send me a text or a chat, and we'll figure it out. All right, guys, I'll talk to you later.